Okay, so this week I wanted to post this and kind of give you a little help on how I view proofs, and maybe the way I do it can help you go through it. Okay, so let's move through. All right, so here you have a kind of the way I view proofs. You have your given information right here. Blah blah in this case, okay? And you're asked to prove this result, whatever that is. Okay, so we set this up the same way. I say, okay, that's going to be my starting point, blah blah, and the reason is given. Okay, I kind of don't even fill this in yet. I kind of skip to the end, and you don't know how many steps it's going to be, but kind of at the end, the last statement you're going to make is the exact same as your proof statement. Okay, now sometimes when people don't understand how proofs work, they put down given, blah, blah, reason given, and then at the very end they put the results, and they put prove over here. Well, that's not exactly right. I view this as the kill shot right here. That kill shot is could be a lot of different things depending on what you're trying to prove, but that's the way I think of it. It's no matter what the proof is, you're building up to being able to use a kill shot that will prove your result. Okay, and if you think of it in these two terms here, really what's nice is you can kind of work backwards or you can work forwards, and you might have to meet in the middle. This is your first set of kill shots. Let's pretend I asked you to prove that two triangles are congruent. Well, the kill shots for triangles are listed right here. You went through them here: side angle side, side side side, angle side angle, angle angle side, and in the rare case of it being a right triangle, you also have the hypotenuse leg. So when you have something like this to prove, that I'm trying to think if there's anything else. No, it's not going to be. For triangles, your last reason is going to be one of these five. Now let's pretend I asked you to prove parallel lines, okay? Really, these are your only options. I sometimes see people put definition of parallel lines, but the definition of parallel lines are coplanar lines that do not intersect. And that's really hard to show. That's really hard to prove that lines don't intersect and that they're coplanar. I mean, it's just, think about how you would go about proving that all lines that you're talking about in this situation are going to be coplanar. So the ones we have to work with are these five that we talked about last week. Now, I included this term consecutive. I'm never going to use it, but it might appear in MathXL or, God forbid, on the air test. So just keep in mind that consecutive means same side. Again, I'm not going to ask you that on the quiz, but just don't be intimidated if you ever see the word consecutive. It means same side. Next, you might be asked to prove that two angles are congruent. Well, there's a lot of different kill shots for this. You can use the corresponding angles postulate or any of the four theorems we just talked about. You might use the vertical angles theorem. CPCTC is something that we're going to talk about with triangles, so sometime this week we'll talk about that. That is one way to prove that two angles are congruent. You could also, if they say something about an angle being bisected, that would be another way. Although this would be very rare. I imagine this would never be used as a final kill shot, but might be used throughout the proof to show that two angles are congruent. Next, you might be asked to show that two segments are congruent, okay? So these are pretty limited, either, using your midpoint or bisector definitions. By the way, the definition of a midpoint, if I haven't said this in class yet, is a point that it falls on a segment that produces two congruent segments. Okay, so that's the definition of midpoint, is the one pretty much that splits a segment in half. And again, we'll talk about CPCTC later this week. Now that you kind of think about this, really the order in which you should really go, and you don't have to write it down this way, but you should definitely think about it this way, is first of all, get your given down, get your free points, but really you need to be thinking about that result and say, okay, this is my result. What is the corresponding kill shot that's going to go with it? If it's prove two triangles are congruent, then really this thing right here needs to be one of the 5 congruence, triangle congruence kill shots, okay? But we don't know which one it is until we fill in the rest of the proof. So let's go through a proof now, and maybe this will make a little bit more sense. Okay, so we're given that L is parallel to M and 1 is congruent to 7, and we're trying to prove that A is parallel to B. Okay, so what we're trying to prove is a parallel thing. Okay, so we know that this is going to be our last step. So here it is down here. We have that already written in, since the person, whoever was designing this, gave us that it was going to be a 5-step proof. We know this is going to be it. However, we should already start thinking about this. We should already start thinking about, okay, what is the possible? Would I be putting side angle side down here? No, because I'm not trying to prove triangles are congruent. I'm trying to show that 2 lines are parallel. So go back to your kill shots page, and you should realize that, okay, there's only going to be one of 5 options down here. Okay, it's going to be either corresponding angles, alternate interior, alternate exterior, same side interior, same side exterior. That's going to be your reason. Those are going to be your kill shots at the end. And I call them kill shots because the proof ends once you use it. It's almost like drop the mic moment. Okay, so let's go through this. The next thing I notice here is that this is information's given, but we haven't written down the other given portion yet. So let's go ahead and write that in. Okay, so we got our given information down. Again, I wouldn't usually write this as 2 steps. I just combine that into 1 step. All right, next thing I notice here is that they give us that this is true right here. L is parallel to M. So if I'm looking at this, L is parallel to M. Why do I care? Well, L being parallel to M means that all the angles across, if this is my sandwich, I should be looking at the angles formed from that sandwich and thinking, okay, which ones does that mean that are congruent? Notice I'm not going this way. I'm not looking at A and B as my sandwich. I'm looking at the sideways sandwich right now, okay? I'm trying to prove that A and B are parallel. Okay, so now I'm looking at 7 and 5, okay? Because since these 2 lines are parallel, 7 and 5 are going to be corresponding angles, okay? And since we have corresponding angles with 2 parallel lines, we can say that they're going to be congruent because of the corresponding angles postulate, okay? Again, corresponding angles are only congruent if the lines are parallel. Well, they gave us that the lines are parallel, so the corresponding angles are congruent. All right, so now I'm looking at steps 2 and 3. So I used step 1. I'm looking at steps 2 and 3 and thinking, how does it help me? Well, I see a connection that they are both 1 and 5 are both equal to 7, so that means they are equal to each other. So that is given by the substitution property, that since they're equal to the same thing, they're equal to each other. Okay, so now we look at this and say, okay, 1 and 5, we are down to our last real thing to fill in, and somehow we have to jump from 1 being equal to 5, and I know it should be congruent, but I got lazy with typing this out, so keep that in mind that these should be congruent symbols. Okay, so A being parallel to B, how does 1 being congruent to 5 prove that? Well, these are corresponding angles, right? 1 and 5 are in the same area, the same section of different intersections. They're both in the top right corner. So they're corresponding angles, but we just showed that they are congruent. So when corresponding angles are congruent, the lines are parallel. That is our corresponding angles postulate basically in reverse. So we use the same reasoning. So that's exactly filling in what we thought it was going to be. So that works pretty well. Okay, here's a proof using triangles now. So our given information's already been filled in for us. Namely that we have RS, that segment bisecting AB. That guy bisects AB, the segment. And M is the midpoint of RS. That's our given information. Okay, so again, our last statement should automatically be this triangle congruent statement. And over here, I'm starting to think about, okay, what's going to go over here? It's got to be one of those 5. Okay, by the way, are these right triangles? Not necessarily. I don't think we're going to be using hypotenuse legs. So now we're down to 4 possibilities of what we're doing. Okay, so that's keeping that in mind. Now we start with the given and we say, okay, what can we conclude from this? Okay, what does RS bisecting AB mean? RS bisecting AB means it cuts AB in half where these two segments, AM and MB, are congruent. So we can say that AM and BM are congruent because that's what it means to bisect. So that's the definition of bisector or bisects, okay? So we used this guy in our proof, so we can kind of forget about this for right now. The next thing, it says that M is the midpoint of RS. Okay, R is the midpoint, or M is the midpoint of RS. So that means that we have two segments that are going to be congruent, one on the left side of M and one on the right side of M. So we can make that statement. And how do I know that? Well, that's what it means to be a midpoint. So that's the definition of midpoint. Finally, we're looking at this and we have two segments that are, or two sets of segments that are congruent, but in order for us to have our, use one of our kill shots, we need to be thinking about our third possibility. So we have two sets of sides congruent. So it's either going to be, for our final kill shot, it's either going to be side, 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 or side, angle, side. It's not going to be ASS. That's not going to be a possible setup. Okay, so either we get the angle included between them or we get the third side. Okay, the third side would be AR and SB. Do we know anything about those? No, we don't know anything about those two. There's nothing given. We can't make any conclusions based off of looks like it theorem. We know nothing about these. All we can do now, we've used our information here. All we have left is to look at the diagram and maybe there's an angle that pops up. Well, if you ever see this problem, folks, this is what I call the bow tie problem. The bow tie problem will 95% of the time make use of the vertical angles here. Because it's a bow tie and it's a crossing intersection here, we have vertical angles at AMR and SMB. So let's go ahead and mark that down. AMR and BMS are going to be congruent because of the vertical angles theorem. We showed that vertical angles are always going to be congruent. So that means that we have two sides. We have AM congruent to BM. We have the other side, RM congruent to MS. And we have the angle included, AMR and BMS congruent. So that leaves our kill shot to be side, angle, side. Hopefully this helps. I forgot to put my sources down, but I will source in underneath the video.